The central angle and the intercepted arc are, what do we know about them? They're the same. Okay, so if you have a central angle, that and the intercepted arc are the same. And then we also learned about what we call an inscribed angle. And what do we know about inscribed angles? What does inscribed mean? What do they look like? Say that again. They're inside the circle. Where's the vertex of the angle? It's on the edge of the circle. So a central angle, the vertex is in the very middle of the circle. It's in the center. And then an inscribed angle, the vertex is on the edge of the circle. And then what's the relationship between the measurement of an inscribed angle and the measurement of the intercepted arc? Yeah, it's 1/2, or you could say the arc is double the inscribed angle. So those are kind of like the two important relationships that we see from today. So we're going to start just with that because that will get us through a bunch of the problems that we have for today. We're just going to look right now at the front of the worksheet. So if you grab your worksheet, markers will be helpful today, or if you have pens of different colors, that can be helpful. Probably like 2 or 3 colors is about all you need. So when I look at problems 1 through 6, and there shouldn't be a lot of talking. When I look at problems 1 through 6, I can see that some of the problems have central angles. So a problem like number 3 has central angles. And then a problem like number 1 or 2 that has inscribed angles. Can you guys see the difference? Okay. So when I'm looking through these, my strategy would be different for the two depending on the problem, and then you kind of have to pay attention to what they're asking you to find. So is it just one angle? Is it more than one angle? Should I use the fact that a whole circle has 360 degrees? Should I use the fact that a 4-sided shape has 360 degrees? Should I use the fact that a triangle has 180 degrees? There's like different things about geometry that we can bring into the problem. So if you look at the worksheet, when these first couple days, the worksheets tell you specifically which circle conjecture to use from the notes. So this is telling you that this is from circle conjecture 1 through 5. Which from the notes, we haven't done all of 1 through 5, we've just done 1, 2, and 3, which is why we're only going to start on the first page, because we haven't gone all the way to 5 yet. Actually, we're just going to do the first little bit. Okay, so if you look at the very first one, do not say the answer out loud, but we're just going to start. What I have found for students, especially when they start doing these, is that using marker is really helpful. So I look at the question mark first. That's the angle that we're trying to find. And so that's where I start with my marker. Sophie, can you take the markers down, please? And then I trace the angle out so that I can see exactly which arc it's working with. So if the angle goes out that far, then the arc that goes with that angle must be arc ST. Does that make sense? So how could we find the measure of arc ST? Yeah, so we know that this one, that we're going to use the idea that a full circle is 360 degrees, and that's how we're going to find the missing arc. So go ahead and grab your calculators. This is definitely a calculator day. Or you can do it in your head. That one's not bad to do in your head, actually. So what is arc ST? $150, okay. So if arc ST is 150, then what's the question mark? It's going to be 75. And remember, that's the relationship from the notes. If we look back at the notes, we know that once you find the arc, the angle is half of that. That's how inscribed angles work. Okay. Let's look at a problem like number 3. Number 3 says you're looking for the measurement of angle XYV. So if we start with the X, XYV is this one right here, and they want the measurement of the angle, so they're looking for this right here. Yeah. Well, I'm going to leave that marking there. Hold on. We're going to ignore the pink. You're right. XYW. I know my alphabet, I swear. Okay, XYV is this one. That's what I meant. It was a typo. Okay. Now, you guys saw before I drew in marker that this one and this one, they had markings on them. Did you guys notice that? Do you guys remember from Math 2 what those markings mean? That they're the same. It was a congruency marking. It meant that the two angles were congruent to each other. So what I'm going to do is I'm going to use a variable that's not being used here. Can anyone think of a letter that's not here already? A. Use A. So I'm going to say that this is A degrees and this is A degrees. And if the central angle is A degrees, then what's the measurement of the arc? It's also going to be A degrees. And how do we know? How do we know that the central angle and the arc are the same? Yeah, it's circle conjecture 1. We learned it in the notes last night. Okay, so we know that that's true because we got the notes. So what we're going to do now is we can look at the outside of the circle and we can see that we have all of the arcs. Everyone see that? So what should we do? Yeah, we're going to figure out what A equals. So how could we do that? Add them all up. Okay, so we can say 155 plus 65 plus 50 plus A equals what? 360 because that's a full circle. Okay? Thanks, Bree. Okay, so then what should we do? Okay? So 2A equals 90. Okay, and then what should we do? Okay. And so A equals 45. Okay, so that means that this is 45, and the arc is, well, let me erase this because that's getting kind of full. So that means that the angle is 45, and it means that the arc is 45 as well. And then the angle and the arc, 45, 45. Okay. So now we can go back to the original problem and see what that was asking. It said the measure of angle XYV. XYV, now that I know my alphabet. So what would the measure of angle XYV be? It'd be 95. How do you know it's 95? Because we only have a 45-degree angle right here. Uh-huh. Yeah, so if arc XW is 50, then angle XYW has to be as well, because that's a central angle and it's arc. And so that means that this is going to be 95. All right. How are your brains feeling? Brains are okay? So what are the two things we're looking at? Because we only have looked at two things. Yeah. Central angles and inscribed angles. That's all we've done. Now, in the pictures, they can become like puzzles. And so I have found that having the markers and drawing on the pictures kind of helps you figure out the puzzle a little bit. So if you look at problem 6, problem 6 is a little bit more difficult than the other two that we looked at. So they want the measure angle CBD. That's what they want the measure of. And then we also have the question mark down here, so we actually have two things that we can look for. So the measure of angle CBD as well as the question mark. Which one do you guys want to try to find first? It doesn't really matter. CBD? Okay. So I'm going to start from C to B to D. C to B to D. So for me, tracing out what I'm finding with my marker is a good first step. Okay, that's how I'm always going to start. And the arc and the angle are always key in these problems. Okay, they're always key. So I have that angle, CBD right here is this angle, and it goes with the arc CD. Is everyone comfortable with that? Does that make sense? Now, there's only one number in the problem, and that's probably going to help us find the answer to this one. So the number in the problem goes with another angle, so what is a good thing to do is to just kind of see how that angle is going to relate to the angle that we are finding. So this angle goes up here with this W, so I'm going to start right here. And what I want you guys to do is start there with that angle and see if you can trace it down and figure out the arc that it goes with. So trace that angle down and see the arc that it belongs to. And what do you guys notice? Okay, so Bree says it has the same arc. Does everyone agree? Same arc? Same arc? Are we seeing the same? Yes? Okay, so if the arc is the same, what do we think about the angle? It's going to be the same as well. Okay, do we have to find the measurement of the arc to make that conclusion, or can we just say that the angles are the same? We can just say the angles are the same? Yeah, they have to be the same. Yeah, they have to be the same, otherwise it wouldn't make sense. So if this one's 31, this one has to be 31 as well. And that was in your notes last night. What conjecture is that? Yeah, it's conjecture 3. Can you guys see how it's conjecture 3? If the two angles have the same arc, then the two angles have to be the same. So these two angles have exactly the same arc. Okay. All right, so now we need a different color. I don't know what color is going to look a lot different from those two. I'm going to use black. Hopefully black will kind of show up. Okay, so now we're going to find the question mark angle. So I'm going to start here with the question mark. And I want you guys to take the question mark angle and trace it out and see what arc it's talking about. So take the question mark angle, trace it out, and see what arc it's talking about. Can everyone see which arc it goes to? Okay, so we traced it. What's the name of the arc that the question mark goes with? Arc BC. Is arc BC a minor arc or is it a major arc? It's a minor arc because it's less than half the circle. Yeah. It doesn't matter. You could say CB. Yeah. CDW. If it was CDW, they probably would have used a little symbol. Yeah, it's a good question. Yeah, they would have probably marked it to show you that it was more than just that little piece right there. Okay, so it goes with BC. Now, if we need to find the measure of BC, could we do it? Don't say it out loud. I want you to discuss it in your groups. We need to find the measure of arc BC. Could we do it? Go ahead and talk in your groups. See what you can do for that. All right, anyone have any ideas? What could we do? Yeah. Okay, so say it one more time. Okay, so this one right here is 62. How do you know? Okay. Oops, sorry. I was off screen. Okay, so this one is 62 because that's double of 31. And then say the rest of it again. Okay, so this plus BC is 180. And then how do we know that this has to be 180? It was half of a circle, and I drew over it, but before I drew over it with the black marker, it went through the dot that was the center of the circle. So it went right through the center of the circle, which means that this is half of a circle. Does that make sense? It's really common in these problems for them to use half of a circle so that you know you have 180 degrees. So we're going to say that 62 degrees plus BC equals 180. Or, you know, you don't even have to write an equation for this. You could just do 180 minus 62 and not even really show your work on that. So if we did that, what's the arc for BC? 118, okay. And then from there, somebody else tell me, if we know that arc is 118, how could we find the question mark angle? Divide by 2. So take the 118, divide it by 2, and then it takes that arc and it gives you the angle that goes with the arc. And so what's the angle? 59. Good. Okay, so I'm going to give you guys a few minutes to work. I want you guys to work on number 2 and number 5, and then I want you guys to see if you can do number 8. Okay? Number 2, number 5, number 8. That's what you guys are working on. Okay, so this one says, if an inscribed angle intercepts a semicircle. So a semicircle is half of a circle, so that's what we need to draw. So what I'm going to do first is draw a dot that's approximately right in the middle of the circle, and then it doesn't matter where you draw this, the drawing will work out no matter what, but draw a line that's a diameter, so it's going to go through that center. And it can be like at any slant that you want, it does not matter. And then I'm going to grab my marker, and then I'm going to use the marker to show that this is the intercepted arc that I'm talking about. So the intercepted arc is a semicircle. And then somewhere else on the circle, it doesn't matter where, somewhere on the other side, I'm going to put a dot, and you can put it anywhere, okay? So I'm going to put my dot right here. You can put yours right here, you can put yours here, you can put it here, 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 anywhere you want, you can put your dot. It doesn't matter where, okay? And then from that dot, I'm going to draw a straight line to one end of the arc and a straight line to the other end of the arc. And what you'll notice is no matter where you put your dot, no matter where you put it, what you ended up with was a 90-degree angle. So tell me why that works, that we could all have different drawings, that I could tell you what was going to happen with your drawing even if I couldn't see your drawing. Okay. Okay. Yep. So it didn't matter where we would draw the angle. If the arc was 180 when we started, the angle had to be 90 wherever it ended up, no matter how we drew it. Does that make sense? So that is what we're saying. If an inscribed angle intercepts a semicircle, then the angle has to be a right angle. So we're going to say then it forms a right angle. There's no other possibility. It's going to be a 90-degree angle. Nothing else. So you can memorize this part or not. This one, if you ever happen to run into half a circle, you're going to be able to remember the 90-degree thing, even if it's not memorized, because you'll be like, oh, cut it in half, it's 90. Oh, cool. All right, so that's, if you memorize it, great. If you don't memorize it, it doesn't mean you're not going to be able to use it. Okay? All right, next page. Let's do some examples. So here, we want to solve for x in the first one, so anytime I know what I'm solving for, I always like to use that part and just kind of trace it with my marker. And so as I trace it out, there's the angle that we're talking about. I can see that the arc that goes with that angle is half of the circle, and I recognize that it's half of the circle because I have this line that goes across that goes through the center. So whenever that happens, I know that they're showing me it's half the circle. So that means that this is 180, which means that the angle that they showed me, the 5x, equals what? 90. So even if you don't memorize that conjecture, we're still using it regardless. So what equation do I need to solve? 5x equals 90. Okay, and then what should I do? Divide by 5. So x equals 18. Okay. All right, how about the next one? Any strategies? Or if you can't see how to finish the problem, how could you at least start the problem? Yeah, figure out where the 52 goes. So when I look at this problem, I'm like, I don't really know how this problem is going to end up, but I do know that I could start with the 52 and see where it goes. So I'm going to start here and say, all right, the 52 goes to this arc, and that means what? Okay, x plus the pink arc is going to equal 180. And what's the pink arc? 104. Okay. And so x plus 104 equals 180. So what's x? X is 76. Okay. All right. The next one is Circle Conjecture 5. So Circle Conjecture 5 says, if a quadrilateral is inscribed in a triangle. So what we're going to do is we're going to draw a quadrilateral, which is any four-sided shape. So it can be a square, it can be a rectangle, it can be any four-sided shape. You can draw any four-sided shape that you want. Okay, so if you want to draw a square, draw a square. If you want to draw a rectangle, draw that. I'm going to draw something that doesn't really look like a square or a rectangle, just to show you that it's going to work with that too. So I'm going to show you one that looks kind of funky. Kind of my weird shape. There we go. Yeah, kind of trapezoidy. Just kind of not anything in particular. Okay. All right. So not really anything. Okay. So, and what I'm going to show you is the relationship between these angles. So I'm going to start with this angle down here. So, and all you need to do is you just need to pick one of the corners. Okay. So pick one of the corners. And then what we're going to do is we're going to draw from that angle to the edge. Draw from that angle to the edge. And then draw the arc that goes with that angle. Okay? All right. And then grab another color, and I want you to look at the corner that is directly opposite of the one you just did. So if this is the one I just colored, then the one that's directly opposite would be this one over here, and we're going to do the same thing. So that is the angle that is directly opposite, so I'm going to trace it out. And trace the arc. Okay. So between those two angles, how much of the circle became the arcs? 100% of it, which means how many degrees? 360. Okay, so if those two angles added together have arcs of 360, then what's the measure of those angles added together? 180. Does that make sense? Okay, so I'm going to write here, I'm going to call this, I'm just going to call it angle 1. I'm going to call this angle 2. And I'm just going to say the measure of angle 1 plus the measure of angle 2 equals 180. So if you have a quadrilateral that is inscribed in a circle, then these opposite angles are supplementary, which means they add up to 180. And the reason we know is because if we trace out their arcs are the entire circle, which is 360 degrees. So if the arcs are 360 degrees, the two angles have to be 180 degrees. This is a neat little trick. It will save you time, but again, you can still do the problem if you don't have it memorized. So circle conjecture 3, 4, and 5 are nice to memorize, but the only ones you have to have memorized are 1 and 2. Does that make sense? I don't want you to feel like you got an overwhelming amount of information today. 1 and 2 you have to have memorized. 3, 4, and 5 are time savers, but are not required to be memorized. Does that make sense? The difference between those? Okay. So from this section, these would be great example problems, but if you don't end up memorizing them, it's not going to hurt you. It's just going to take a little bit more time for some of those problems. Okay. So if we look at this, we're going to go ahead and finish that sentence, actually. If a quadrilateral is inscribed in a circle, then its opposite angles are supplementary. Its opposite angles are supplementary, which means they add to 180 degrees. So it's a time saver, that's all it is, but you can still do the problem even if you don't remember that. Okay, so if we look at example 12, it says measure of angle HIF. So from H to I to F is kind of what we would think of as angle I. H to I to F is this angle right here. And they tell you that that angle right there is 92. H to I to F. H to I to F is 92. I to F to G. I to F to G is 84. I to F to G is 84. Okay, and they want you guys to find the remaining angles. So if we want to use what we just learned and save ourselves some time, how could we find the remaining angles? Yeah, so 180 minus 92 is, you're close, not 98, 88, good. 88. So the one that's across from this one is going to be 88. And then 180 minus 84 is going to be 96. And so the one across from that is 96. So GHI is this one. That one was 96. And then FGH is this one. That's the 88. It's not the only way to do the problem, it's just faster. Okay. How are your brains feeling? They feeling okay? Yes? Maybe? Yes? No? Yes? Yes. Okay. All right, go ahead and grab your worksheet and do number 4. You can do number 4 on the worksheet. You can also do number 7 on the worksheet. Number 7 does not use circle conjecture number 5. It seems like it might, but it does not. So number 7 on the worksheet you can do, it does not use circle conjecture 5. It's just a regular circle conjecture number 2. It's just a little bit more complicated. So if you want to work on 4 and 7, and then we'll take some more notes. Yeah. Mm-hmm. Absolutely. Yeah. So you did it as though you didn't have the rule memorized, and that's fine. Yeah. It's always a valid way to do it. Everyone see how I started the work on number 7? So I looked at the angle that had a marking on it, you know, that had something measured on it. And then I looked at the arc that it went with. And then I did 2 multiplied by the angle equals just 1 of the arc. Does that make sense? The alternative would have been to take the arc and multiply it by 1/2, so that 1/2 of the arc would equal 1 of the angle. That would have worked as well. So you could do it either way. But this one felt a little bit more comfortable to me. So I'm looking back at the notes, and I can say, if I take the angle and multiply it by 2, I get the arc. Take the angle, multiply it by 2, I get the arc. Or I could take the arc and multiply it by 1/2 and get the angle. Yes? Yeah, so I set it equal, and then I still have to solve. Yeah, so this is just me showing, this is kind of how I'd set up the problem. Yeah. Okay. All right, so the next part that we are on is Circle Conjecture 6, which kind of moves on from inscribed angles and central angles, although it is very similar. So it says, if you have an angle that is formed by a tangent line and a chord. So a tangent line is a line that is up against the circle. So I'm going to show you guys what that looks like. Annalise, did you have a question? What's your question? You, since you guys did not have class today, I'm not going to have you guys do the notes. Yeah. So here's your tangent line. Remember, a tangent line is a line that cuts the circle. It just hits the circle at one point. And so it's outside of the circle. It has one point that it touches, and it touches right here. This is called the point of tangency, is the point where it touches the circle. Point of tangency. So there's the point of tangency, and then we have a chord, and a chord touches the circle in 2 spots, and it's inside the circle. So I'm just drawing these to be approximately the exact same picture, and then I'm going to mark them up a little bit differently. So for one of the pictures, I'm going to show that the angle I'm talking about is this inside angle over here, the smaller one, and then for the other one, I'm going to show that I'm talking about this angle over here, the bigger one. So these kind of look like inscribed angles, but they're not actually inscribed because the full angle isn't really inside the circle. It's like partially outside the circle because that tangent line is outside the circle. But the relationship is still the same. So I'm going to go ahead and draw on these. So you have the angle right there, and then the arc that goes with the angle looks like this, which is kind of interesting. And then for the other one, the arc that goes with this angle looks like this. So it's not called an inscribed angle, but the relationship is the same. Is that the angle itself is half the measurement of the arc. And I don't know if that makes it less confusing or more confusing. For me, it helps me to remember it at least, that the relationship is the same. In my mind, these are the funkiest ones. The kind of nice thing is that these pictures are not as common in the unit. They show up, but they don't show up all the time. Inscribed angles show up all the time. These, a few of them sprinkled here and there. Okay, so we don't have a name for it. We just know it's similar to an inscribed angle, but technically it's not the same thing. We can't call it that. It just looks kind of similar. Okay. All right, so if an angle is formed by a tangent and a chord, then the measure of the angle is half the measure of the intercepted arc. All right, go ahead and turn the page. All right, so if you look at this one, we've got this little dot right here on mine, well, on all of yours, because I printed all these, right? You can see it's red. So we do have a line through the center of the circle, which means it has split it into half a circle, which is really helpful. So let's go ahead and kind of go through and solve for all of the missing things that are listed here. So I think the first one, the one that's probably the most comfortable for us, is going to be this 35-degree angle. And I'm not going to color it this time because I'm going to leave the coloring for a different angle that's a little bit more difficult for us. But if we follow it out, if this is 35 degrees and we follow it out, what arc does it go with? It goes with LJ. Yeah, X is actually the angle. Can you see that X is the angle? Yeah. Okay, so LJ is what it goes with. So if 35 degrees goes with LJ, the arc, then what is the measure of the arc LJ? 70. Perfect. Okay, so we're going to show that the arc LJ is 70, and I am going to draw on the arc LJ and show that that's 70 right there. Okay. Okay, now from here, let's trace the y out. We can trace the y. The y is which arc? It's QJ. Does anyone know the measure of QJ? It's going to be 2 of the y's. Yeah, so Nate, why'd you say it's 110? Yeah, we can tell that the circle was cut in half, right? So if this arc is 70, then that arc right there would have to make the rest of the half circle. So it's got to be 110. Okay, so let's label that. That's got to be 110. And then we were saying that that had to be 2 of the y's. So if that's 2 of the y's, then what would 1 y be? 55. So if the arc is 110, then the y has to be 55. Okay. Okay, so we know what that is. All right, so now we're going to find angle X. So does everyone see that angle X is what we just learned about? I'm going to draw it in the black marker so we can see how it's what we just learned. Here's our tangent line, and then here's our chord. Everyone see how it's what we just learned? So tangent line, chord, and then we have our arc of 70 degrees. So what is angle X? It's 35 degrees. Everyone see how it's 35 degrees? So if we look at the picture we just drew, it's very similar to this one right here. The first one we drew, the little one. So angle X is half of 70, so angle X is 35 degrees. So X is 35, Y is 55. We got it. Okay. Next, if a line is tangent to a circle. So we're going to go ahead and draw another tangent line. And we got the point of tangency like this. Okay. So then the line is perpendicular to the radius or diameter, could be either, drawn to the point of tangency. So if a line is tangent to a circle, then the line is perpendicular to the radius or to the diameter, that is drawn to the point of tangency. So what we're going to do is we're going to draw a point that looks like it's in the very center of the circle. And the reason we're doing that is because that's the definition of a radius, right? A radius goes from the center of the circle to the outer edge of the circle. Would you guys agree with that? From the center of the circle to the outer edge of the circle. Or if it's a diameter, then it has to cut all the way across the circle and it has to go through the center. Agree with that? Yes? Okay. So they're saying if that line touches both the center of the circle and the point of tangency, then it has to form a 90-degree angle. That's what this is saying. So if we draw this line, either a radius like this, or it could be a diameter. A lot of times I've noticed that it ends up being a diameter. Then this has to be a 90-degree angle. Has to. There's no other option. So it could be a radius, or it could be a full diameter. Doesn't really matter. Either one would work. Okay? All right. So there's a couple different ways this shows up in problems. It can show up in problems when you find angles that are missing, because then you have 90-degree angles. But it can also show up with right triangles using the Pythagorean theorem. So if we look at number 14, on number 14, they only drew half of the tangent line. They didn't draw the whole thing. So here's the point of tangency right here, and here's the rest of the tangent line. They just didn't draw it. And then there's OP, that's the radius. So that means that this is the 90-degree angle. And they want you to find the measure of OR. So if you have this is 5 and this is 12, how would you find the measure of OR? Yeah, 5 squared plus 12 squared equals, I'll just go ahead and call it x because that's easier to write, equals x squared. So we got 25 plus 144. And that's 169. What did you say? Okay. And then what does the x equal? 13. So that's one way the problems can work out, is that they can be setting up a Pythagorean theorem problem. Or the other way the problems can be working out is like problem 15 or 16, where they're setting you up to find a missing angle. So in problem 15, we have two tangent lines. So here's one tangent line, there's our point of tangency, and there's our radius. So this is a 90-degree angle. And then here's another point of tangency. And here's a radius. The ON is the radius. There's a 90-degree angle. So we have a four-sided shape. How many degrees are in a four-sided shape? Think square, think a rectangle, 360. We do. They're over there. They say segments of a circle notes. So when we subtract those, what do we get? $63. Okay. And then for this one, here's our tangent line. And then here we don't have a radius, we have a diameter. There's the center. We have a diameter. our 90-degree angle. So we can do 180 minus 90 minus 38. And then what do we get? $52. Okay, so I think that I'm going to leave the rest of the notes. We can probably finish them in class tomorrow. So what I want you guys to finish from the practice packet is... Oh, shut off, don't shut off. What I want you guys to finish from the practice packet is I want you to finish all of the first page, 1 through 8. And I want you to finish 9 through 16. So you're going to do 1 through 16. 1 through 16 is what you're doing on the practice packet. Does that seem reasonable for the practice packet? Can we do that? Okay. And then we're going to start the video. You guys are going to do the video on the segment notes tonight. We are a little bit behind, but not terribly behind. We're going to try as much as we can to get that quiz in before spring break, just to salvage your guys, to keep you guys from having the difference in homework over spring break. Okay, that's kind of what our goal is. All right. Any questions? We're good? Okay, so 1 through 16. I'm going to go ahead and hand out the sheet for the video notes, but see if you can get most of 1 through 16 done now. Let me know if you guys need help once you get to 11, 12, 13, 14, because I can explain those. They use the ideas, but we didn't do examples that look just like that, so if you need me to do one of those, we can.